What we're going to do today is we're going to look at how we can use electronegativity to help classify what type of chemical bond is going to form between two elements. What we've looked at so far is ionic bonding, but now we're going to add another type of chemical bond that's called a covalent bond. All right, so what we know is a chemical bond is a force that holds atoms in a chemical compound together. Why elements form chemical bonds is to change their configurations. They want to obtain those full outer shells, like the noble gases, in order to become more stable. In any type of chemical bond, it's the valence electrons that are being involved. In an ionic bond, we have that complete transfer of electrons occurring between a metal and a nonmetal. The metal loses electrons, the nonmetal accepts them. You have the positive cation, the negative anion being formed, and those oppositely charged particles are then going to be attracted to each other. What happens in a covalent bond is electrons are generally going to be shared between nonmetals in order for them to change their configurations to obtain those full outer shells. So what I want you to do on this check for understanding slide is go through and identify whether or not an ionic or a covalent bond would form between the two elements, and then state whether or not the electrons would be transferred or shared. Magnesium and oxygen, metal nonmetal, ionic, transferred. Nitrogen, oxygen would be a nonmetal nonmetal, so covalent bond, and the electrons are going to be shared. Carbon and chlorine is going to be nonmetal nonmetal, so a covalent bond and electrons are going to be shared. Chromium and fluorine, you have a metal nonmetal, so an ionic bond, and electrons are going to be transferred. What we're now going to do is we're going to use electronegativity in order to identify whether an ionic or a covalent bond would form. Just remember that electronegativity is a measure of how strongly an element attracts electrons in a chemical bond. What we know is for the trend in electronegativity, it increases as you go from the bottom to the top of a group, and then it increases as you go from the left to the right across a period. So generally, metals have low electronegativity values, whereas the nonmetals have high electronegativity values. What we're going to do is we're going to take the difference in electronegativity between two atoms and use that difference to figure out whether or not an ionic or a covalent bond would form. So if you take the difference in electronegativity and it's 2.0 or greater, you're going to have most likely an ionic bond being formed, and the electrons are going to be completely transferred. If the difference is less than 2.0 all the way up to 0, you're going to have a covalent bond being formed instead, and the electrons are going to be shared instead of completely transferred. So in order to solve these types of problems, you need an electronegativity chart. So you are provided an electronegativity chart. Just please make sure to only use the one that I gave you. Sometimes if you look online, different electronegativity charts are going to give you different values. So to make sure all of our answers are consistent, we're only going to use the one that I gave you kind of at the start of class. There's also a digital copy of this electronegativity chart uploaded into the file section, but anytime you need an electronegativity chart for an assessment, you'll be given one just like how you're given the periodic table. So on the electronegativity chart, below each element's symbol is its electronegativity value. Notice how there are no noble gases. Noble gases generally don't want to form chemical bonds, so we're not going to assign electronegativity values to them. So to solve these types of problems, you'll take the difference in electronegativity for the two elements. Just make sure you're taking the absolute value difference. So disregard any positive or negative symbols. You're just looking for the magnitude of the difference between them. So lithium and fluorine, the difference would be 3.0. Since that's greater than 2.0, an ionic bond is generally most likely going to form. What I want you to do is try the check for understanding problem. So what type of bond is most likely to form between carbon and hydrogen? That difference is going to be 0.4, so that's most likely going to be a covalent bond where electrons are going to be shared back and forth between those two elements. All right, so you can go through and solve this slide. What I want you to do is find that absolute value difference for those two elements, their electronegativity values, what type of bond is most likely to form, and would that mean that the electrons are being transferred or shared. So that first difference is 0.5. covalent bond shared, 2.5 ionic transferred, and then for the two hydrogens, whenever you have two of the same exact nonmetal, the difference is always going to be 0. That's always going to be a covalent bond where the electrons are being shared. So now what we need to do is we understand that a covalent bond involves the sharing of electrons back and forth. But we're going to further classify a covalent bond as being either polar covalent or nonpolar covalent based off of how the electrons are being shared between those two elements. So in a nonpolar covalent bond, the electrons are shared equally between those two elements. Generally, their electronegativity values are either equal or very close to each other, so one element really isn't able to have a stronger pull than the other one, so the electrons are being shared equally back and forth. You can see on the image on the right, for this bond between the two hydrogens, the electron density cloud is symmetrical because those electrons are being shared equally back and forth between those two elements. The other type of covalent bond is going to be a polar covalent bond. In a polar covalent bond, the electrons are shared unequally between the two elements. So what happens in a polar covalent bond is one element has a slightly higher electronegativity value, so it pulls the electrons a little bit closer towards it. That causes an unequal or asymmetrical distribution of electrons, and that leads to what's called a polar covalent bond. So to kind of look at this concept in a little bit more detail, between chlorine and hydrogen, a polar covalent bond is going to form. Chlorine has a slightly higher electronegativity value, so it's able to pull the electrons a little bit closer towards it as they're being shared. So you end up having this asymmetrical distribution of electrons between these two elements in this chemical bond. So what happens is chlorine is pulling the electrons a little bit closer towards it. That results in the chlorine side of the bond being partially negative, whereas the hydrogen side of the bond is partially positive. This idea that in a polar covalent bond, you have one side being partially negative and the other side being partially positive, that results in there being what's called a dipole being formed. So think of di meaning two, pole, you have these two different ends of the bond. The one end of the bond is partially positive and the other end of the bond is partially negative. So sometimes to represent that a dipole is formed between two elements, we use a certain symbol to kind of note that. And if you look between chlorine and hydrogen, the end of the bond that's partially positive, we kind of start to draw what looks like a plus sign, but then we draw an arrow going towards the side of the bond that's going to be partially negative. So in a polar covalent bond, you have a dipole being formed where one end of the bond is partially positive and the other end is partially negative. All right, so now what we can do is you have to understand that there's different strength dipole moments. So based off of the difference in electronegativity, you can have different strength dipoles being formed. This concept of dipole moments is going to become more important towards the end of the unit when we discuss polarity of molecules, but just understand these different dipole moments have different strengths based off of the difference in electronegativity for the elements. What you need to understand is depending on the electronegativity difference, you're going to end up having different strength dipoles. And this idea that not every dipole has the same exact strength or magnitude is going to become important when we look at the polarity of molecules later on in the unit. All right, so at this point, you should be able to take the difference in electronegativity and identify whether or not an ionic, a polar covalent, or a nonpolar covalent bond is going to be formed. If the difference is 2.0 or above, that's going to be an ionic bond and electrons are going to be completely transferred. If the difference is 0.4 to 2.0, you're going to have a polar covalent bond being formed. Electrons are going to be shared unequally and that dipole is going to be created. If the difference is 0.4 to 0, you're going to have a nonpolar covalent bond. Electrons are shared equally and there is no dipole being formed. So what I want you to do is look at these three images and identify which image would kind of represent nonpolar covalent bonding, which image would represent polar covalent bonding, and which one would represent an ionic bond. So the top one would be a nonpolar covalent bond, because you could see they're kind of sharing back and forth equally. The next one would be a nonpolar covalent bond, because they're being shared unequally back and forth. And finally, that last one would be an ionic bond, because you can see there was a complete transfer occurring. All right, so what I want you to do is go through and find the electronegativity difference, identify whether or not it would be an ionic bond, a polar covalent bond, or a nonpolar covalent bond. And would that mean that the electrons would be transferred, evenly shared, or unevenly shared? All right, so first one would be 1.0. It's going to be polar covalent. That's the uneven sharing of electrons. Next one would be 2.1. That's ionic. Electrons would be completely transferred. And that last one, the difference would be 0. That's going to be a nonpolar covalent bond, and the electrons are being shared evenly back and forth.